Hello everyone, welcome to my presentation on stroke prediction using machine learning. My name is Kirti Yadav, and in this project I will share how we can use data and algorithms to identify patients at risk of stroke. First, let's understand what a stroke is. A stroke is a serious medical condition where blood flow to the brain is blocked or reduced, which can lead to severe health consequences or even death. Why is it important to predict strokes? Because early detection can save lives. This is valuable for doctors, hospitals, and healthcare systems. Machine learning plays a key role here by analyzing patterns in patient data to estimate the risk. The main objective of this project is to develop a machine learning model that can predict the likelihood of a patient having a stroke based on their medical and demographic information. The goals are to build an accurate prediction system and to identify the key factors that contribute most to strokes. Our dataset comes from Kaggle and contains 5,110 patient records, and the dataset includes numeric and categorical data. The target variable is a stroke, where 0 means no stroke and 1 means stroke. One important note, there is a class imbalance, meaning stroke cases are much fewer compared to non-stroke cases. To prepare the dataset, I standardized column names, checked data types, and handled null values. I also inspected duplicates to ensure data quality. The main goal here was to make sure the dataset was clean, consistent, and ready for pre-processing and modeling. When I plotted stroke occurrence against age, younger individuals had a very low incidence of strokes, but as age increased, especially beyond 60 years, the number of stroke cases rose significantly. This makes sense from a medical perspective. As we age, our blood vessels become less flexible, cholesterol deposits increase, and other health conditions like hypertension or diabetes are more likely to develop. All of these factors contribute to a higher risk of stroke. In the BMI graph, the middle line, which is the median, is slightly higher for stroke patients compared to those without stroke. This means that, on average, stroke patients weigh a bit more. We can also see some dots far above the rest. These are outliers, meaning a few stroke patients had much higher BMI than the rest. For glucose levels, the difference is even clearer. The median is higher for stroke patients, and there are several dots far above the whiskers, showing a few stroke patients had extremely high glucose levels. So, the graphs show that stroke patients tend to have higher BMI and glucose, and also more cases with unusually high values. An interesting observation came from smoking status. Surprisingly, the group with the highest stroke rate was not current smokers, but those who formerly smoked. This could be because many people quit smoking only after they develop health problems. This group might already have accumulated years of damage to their cardiovascular system before quitting. It's also possible that this group is older on average than current smokers, which could be influencing the results. When analyzing work type, self-employed individuals had a higher rate of stroke compared to other categories. One possible explanation is lifestyle and stress. Self-employed people may face irregular work hours, lack of access to regular health care, and higher stress levels from running their own business. All of these can contribute to cardiovascular strain. However, it's important to note that this is just a correlation. The dataset doesn't directly prove that self-employment causes stroke, but it does suggest that work-related lifestyle factors may play a role. I used two main machine learning models in this project. First is the decision tree. The good thing about decision trees is that they are easy to understand and can work well even if the data is not perfectly balanced between stroke and non-stroke cases. They can also handle more complex patterns in the data. Second is logistic regression. Despite the name, it's actually used for classification, not just regression. It works by calculating the probability of a patient having a stroke based on their information. This model also lets us see which factors push the probability higher or lower, which makes it useful for understanding the impact of each feature. To prepare the data for my models, I did a few things. I removed columns that were not useful, like ID numbers. I converted categories like work type and smoking status into numbers so the model could understand them. I scaled some features to make the logistic regression work better. Finally, I split the data into 80% for training and 20% for testing, making sure the stroke and non-stroke cases stayed balanced. To see how well my models worked, I looked at accuracy, which tells the overall correctness, precision, recall and F1 score to see how well the models detected strokes correctly, confusion matrix, which shows the true and false predictions in detail. When I looked at which factors mattered most, age was the strongest predictor of stroke. Other important factors were smoking status, BMI, work type and glucose levels. Logistic regression also showed us specific risky categories like people who formerly smoked or are self-employed. So my key finding is older age and high glucose levels are strongly linked to stroke risk. And the limitations in the data are some data was missing and the data was imbalanced, which could affect the model's predictions. Machine learning can help predict stroke risk and support doctors in identifying high-risk patients. In the future, we can improve this work by using a larger and more balanced dataset, trying other algorithms like XGBoost or neural networks, adding more detailed patient history data for better predictions. Thank you for listening to my presentation. I hope this gave you insights into how machine learning can help in healthcare, especially for life-saving predictions like stroke detection.